All right, good afternoon. I hope everyone's having a great day so far and enjoyed all the keynotes that we saw. Since we're literally on the clock, we're gonna go ahead and get started. We're gonna talk about how to get up and running with Puppet in 45 minutes or less. So this is our introductory slide. This is me. Can you all see this? It's not moving.
It's showing on my screen.
Yeah.
So let's see if we can get this other one to update for us.
There you go.
There it is.
So that's me. I'm me, and this is Jeremy. And like Josh mentioned, I'm a technical solutions engineer out of the Portland headquarter office. And if you all were listening closely, Jeremy's the senior manager for the TSEs, so that means he's my boss, which is really cool. And he's also gonna be helping me with this talk today. So we have a few goals for today. We are going to learn how to stand up a master. We are going to install a Linux agent and a Windows agent. And we're also going to use a module from the Forge. So we're gonna learn how to install that, configure that, and then we're gonna look at some reporting elements within the Puppet console for how to really leverage a lot of value out of your Puppet deployment.
Cool, let's do it.
Real talk. So we got to get started here at the beginning with some honest conversation. Some people call that real talk. Truthitude or falsivity, by the way, those are not real words. Those are words that I created, so do not use them and reproduce them thinking that's a Webster dictionary term. And the truth of the matter is, it's gonna take more than 45 minutes to get up and running with your Puppet deployment. But not because Puppet isn't fast, and not because we don't want you to get up and running in 45 minutes or less, but because there's some environmental factors that are gonna play a role in how quickly you can install the various packages you need to run the installer script and to get your agents up. And so dependent on network connectivity, what kind of VM you're running, if you're doing it in the cloud, if you're doing it locally on your local machine, those things are going to influence how fast things download and how quickly you get up. But what we're gonna do today is walk you through those steps so you know where to find everything and how quickly you can get up.
Yeah, don't be too hard on yourselves.
Right.
This is not our first rodeo. We've done this a couple times.
That's right. So this diagram that you're looking at right here is just a really great way to see a Puppet deployment. And the architecture of a Puppet deployment is a very basic client-server one. So we see here that we have the Puppet master operating as that server, and we have the clients below. And if you'll notice, the clients are different types of machines. We've got a Windows machine, we've got a Linux machine, or anything in the Nix distros is also compatible with Puppet, as well as a network switch, and then a cloud. And the cloud is representing not just cloud technologies, but also container technologies. So with Puppet, you're able to actually manage all types of OSs with a singular master that is able to speak to any kind of operating system or tool that you might be using. So what is Puppet? Before we really kind of drill into the nitty-gritty of how it works, let's get a great and conceptual understanding of what it is. So I'm gonna do that by telling you a little story. And the story is one that, if you'd like to close your eyes and visualize this as you, go ahead, but I recommend you keep them open, is a world in which you're a business leader. Let's say you are part of a senior IT team, and you've actually realized that there is an ongoing problem with the SSL configuration on a lot of your machines. And you actually don't know what's going on. And it's repeatedly happening, and it's affecting your bottom line because these SSL configurations are really, really vital in operating your point of sale system. And you need people to be able to buy and sell your products online, using a browser to log in, to look at resources, being able to complete purchases, etc. But this problem is repeatedly happening, and quite frankly, you're losing money. This is actually a real use case of a customer that we have. And what they discovered was that there was a problem with their time configuration. And the SSL configuration was actually dependent upon that time configuration being set properly, and it wasn't. So they were losing thousands of dollars every day because they couldn't identify this problem. Once they adopted Puppet and had Puppet managing their time configuration, they were able to squash this problem and actually have insight into when it was occurring and where it was occurring. So this is just a story time example of how Puppet actually is going to be able to identify problems, help you create that stable state that you want in your environment, and then also assist you in maintaining that stable state over time.
Cool. No pun intended, right? Story time. Okay, we'll get into that.
Maybe. Be on the lookout for that. There might be another pun. So now, how does Puppet actually work? So we see here that Puppet is going to be running with a Puppet master, this box right here, and it's going to be communicating with what we call agents. So these boxes right here, and you see we have several boxes. These agents, upon Puppet run, are going to be sending some key pieces of information to that master. These pieces of information are called facts, and they're simply inventory items about your system. What's the operating system? Where's the data center? And these facts out of the box are pre-populated for the machine once an agent is installed. So already you're getting value out of your Puppet deployment because they're telling the Puppet master some key things about themselves. And then with these facts, the master is actually able to filter out what agents are going to be receiving the configurations that we want to apply. And so this is done via catalog. And this catalog just holds the configurations we want and is managing the resources that we want on the specific machines that have been filtered by the facts. So when you trigger a Puppet run, the correct nodes are actually going to receive the configuration that they need. And then you see here that just several boxes lit up, 3 of the several boxes lit up, because not all of our systems actually need to receive that configuration. We have a heterogeneous environment with Windows and Linux machines, and we actually just want our Linux machines to receive that configuration. So those 3 Linux machines receive the configuration. A little nuance though, not all 3 of them needed that configuration. 2 were already in that set desired state, and 1 wasn't. So the beauty of Puppet is also in the reporting element. So the reporting is going to tell the master, hey, listen, turns out 2 of the 3 agents were in the correct state. So I actually made changes on that 1 box, and those 2 other ones, I'm gonna report on them, but they're exactly as you asked for them to be. So already within a Puppet run, you're able to not only identify key attributes about a system, but use those attributes to send out the correct configurations and then get valuable reporting, all within a 30-minute cycle, which is how often Puppet is running out of the box.
Cool. How do we get this going, Grace?
That's a great question, Jeremy. So here are the pre-steps. I am running with Virtual and Vagrant. So that is how I'm spinning up these VMs that we're using today. There is a control repo out there in the wild that I will share with you that you can use. And using that environment, you're able to simply just clone my repo and then Vagrant up to get started. There's a README that I will flesh out a little bit more based on the questions today and have available to the public so that you can actually get started at the point that I'm at right now. But if you want to do another type of virtual machine, so if you want to use, AWS instance or anything like that, you can, and follow the instructions that we're going to provide today.
Yeah, it's one of the values of Puppet, right? The same code will run whether it's a cloud instance, a virtual instance, physical server, whatever. So pretty cool.
So step 1, we're going to first install the master and then install some agents. And we're actually going to run a video that I'm going to speak over in real time to get you started on how to do that.
All right, here we go. I'm going to fire this thing up. And is this video, I take it, is actually on YouTube as well?
That's right.
Cool. So you'll be able to follow this thing out and figure that out as well after the fact.
Is it loading?
Cool. Well, yeah. And, sometimes when you move your Wi-Fi, you need to, turn it off and on again.
That's right.
It's one of the most valuable skills in IT, right?
That's right.
So we'll fire this thing up, and then and if it doesn't show up, then we'll just kind of walk you through it manually.
We can definitely do that verbally.
We have real machines as well.
That's right.
Cool. So the basic idea, as we try and get this up, is we'll actually show how you do the installation on the master.
So we're going to take you to the URLs that you actually need to get up and running while we're trying to get some internet connectivity going on up here. And that,
cool.
Did it?
No, so I'm just gonna show folks, what you would have to do.
Excellent. So what you're going to do is you're going to actually need to go to the website. And when you go to the website, what it's going to do is there's a downloads page where you have the option of identifying what master machine that you have. So you can specify what version of Linux you're running and what that system is. We're running on a CentOS 7 box, so we're going to actually just grab the installer for that. And so you simply go to the URL and you select exactly the installer you need.
Yeah, I've got an EL7, works on all the enterprise Linuxes, RHEL, CentOS, whatever. So we download the tarball, extracted it.
Tar it, and then once you do that, you're actually going to go into that directory, and there are 2 scripts that you really want to pay attention to, both the installer script and the uninstaller script. And you just simply execute the installer script, and what it's going to do is it's going to then prompt you. And the prompt that it's going to make is one of how you would like to run that installation. You can do it in text mode if you would like, or you can also run that installation in the browser. And so I recommend...
We don't need to run it now because we've already got this
We've already run
installed,
it, but I recommend the browser run because what that allows for you to do is actually see what's happening. And you select that you want a monolithic installation and you specify what the fully qualified domain name is for your master. So once you've made those two selections, you're then able to trigger that installation process, which allows for you to actually view the logs so you can see what's happening on the back end. Once that installation is complete, you'll be able to then select a button that says, let's get started, and you'll go to your overview page in your console.
Let's go there. That's local. We can check that out for sure. So here,
See it.
Boom.
Perfect.
And here's where you'd come in to your browser.
And so this is the overview page that you're going to get. And what it's going to show you are a few key items about what's happening in your environment. It's going to show you what are the nodes you currently have in enforcement that are running Puppet. It's going to also show you what nodes are not reporting, and it's going to list what those nodes are and when they last had a run. So these are some key items here in getting started. So once you're able to determine that you have the appropriate nodes up and running with Puppet, you can then begin the process of actually utilizing some sort of Puppet module in order to classify and configure something in your environment. If you remember, we were talking about time earlier in that use case I presented with how NTP or time was part of the issue. So we're actually going to modify time. We're going to use NTP, which is a network time protocol for Linux machines, and WinNTP, which is the Windows variation of that, to manage exactly what time server is controlling time on these three boxes.
Cool. So we've got a module here that does just that.
Exactly. So this is the TSC time module, and my team was awesome in helping me prepare this. Jeremy wrote a lot of the code for the Windows portion, and then a teammate and I wrote a lot of the wrapper for the Linux portion. So you have applicable code that you yourself can actually go find here in the Forge, which is a repository of modules. There's over 4,500 modules, so feel free to go and search for any latest technologies that you're using on your team as well.
Cool.
So in order to actually install the module, it's actually one command, and that command is puppet module install. There's a few ways to get modules installed, but this is a great way to do it straight from the command line, and it allows for you to see those changes available immediately.
Cool. And so again, this will depend on the internet, so let's see if it's up or not.
Yeah.
So we'll try and install, and let's see. It's trying to talk to the Forge.
All right.
And get that thing installed. Ooh.
Did we just get mood
that
music?
Was awesome.
Yeah. Thank you, Enrique.
That could have been a really drum roll, but that was much nicer.
Yeah.
Cool. It looks like it worked actually.
Excellent. That's what I wanted to hear. So you see here that we have the TSC time module installed. But you also see that there's some other modules that it seemed are nestled in that module. So what's really cool about using Forge modules is that Puppet is going to handle that complexity. It knows what other dependency modules there are, and to also make sure that those are available. So we have that Puppet Labs NTP module here, as well as that TSC WinNTP module, and then Puppet Labs registry and standard lib, all the modules that we need in order to make sure that this is going to work on our system.
Cool.
Perfect.
Now we got the module.
Yeah.
We didn't show in the video actually installing an agent.
No.
But that's something that we have currently installed, and
That's right.
I think we should probably just show for folks that are wondering,
Yes.
when you get that Linux box up, what you can do to quickly install that agent.
Exactly. So once your master is stood up, there's going to be a command that you need to run on that same box, or not on the master's box, but on the other box that you want to manage. And it's this curl command right here. So you're simply going to just copy and paste it and run it on the machine, on that target node that you want Puppet to be managing. So that's going to be this box right here, this Linux machine we have up and running. So you simply run that, and it's going to install the agent for you, and it's going to create an SSL directory that's going to actually let you sign the cert via the browser. So once that happens and it runs, it communicates with the master and says, hey, listen, I have an unsigned cert. I really want to be one of the nodes you manage. Could you please allow for me to do so? And so since the master wants that to be a node it's managing, it simply says, yes, you sign the cert, and then you'll be ready to go. And it'll check in with the master, and it'll populate those facts that we looked at earlier. And you'll be able to use that to create those configurations in your environment.
Cool.
Awesome.
All right, so we've got some content, we've got some nodes. What do we do next?
I think we're ready to actually classify something and run Puppet.
Cool.
So let's go ahead and let's get in our configuration view right here in the classification. So you're gonna create a node group.
Wait, how are we going to even classify these things? Do we need to look at what the facts of these machines
We're
might
totally
be?
going to look at those facts.
Okay.
So before you even start creating your groups, you want to be able to identify what machines you want to have membership into that group. So if you go to the node that you want to view, let's say here, this node right here.
Yep.
And you go to node details. These are the facts that I talked about earlier. So as you can see, there are tons of facts that have to do with everything from the kernel version to the IP address to where's the data center. Cool thing about facts, FYI, you can create custom facts. So if there's an attribute item that's not already here that you want to see, you can create them. So you're going to simply just figure out what some key attribute items are that you want to use for your facts. I love OS family. I feel like you can't go wrong with that one. And so I like to use that as often as possible. And you'll see here that it's also telling us what the value is for that. And so the value is Red Hat. And the facts are case sensitive. So you're going to want to be sure that you capitalize things that should be capitalized and you keep things lowercase that should be lowercase.
I just did a little copy paste thing. So.
Or you can just copy paste.
There you go.
IT secrets. These are the IT secrets that everyone's been dying for.
Turn it off and on again, cut and paste. It's amazing.
Exactly. And so you're simply going to go back into that classification view, and you're going to create a node group. We're going to call ours time servers. And so we have already created that group for you all today, and it's going to tell you to log back in.
There we go. Actually, that was just a cache page.
Cache thing.
Yeah,
all right, so we're going to create that group. So let the magic begin.
Cool.
And so we're going to simply call it time servers. I recommend that your node group name be an applicable name that you can remember what the function is of the code that lives there. So with time servers, you know that you're going to be probably managing the time servers across your Windows and Linux machines.
Sure.
So put a small description to help your teammates, right? Maybe you're not always going to be the person managing the Puppet code, so you want to make sure that other people also know what's happening.
Cool. Done.
Excellent. So now you're going to go into that node group, and you are going to use the facts that we decided are really applicable here.
Oh, there they are.
Yeah, they self-populate. So you're going to select OS family.
Okay, can I just type it? OS
right.
fam. Oh, there it is. Perfect.
It is. And then you're going to keep the operator as equals, but you have the option to change the operator if you'd like to not equals or to anything else that you desire. And then you're going to select that value that we copied earlier.
There it is.
And we're going to add the rule. And so here we see here that adding the rule, there are two matching nodes. So when we go to that tab to view what those two nodes are, it's going to tell us that it's our Linux box and our master, which is exactly what we want to see. So go ahead and commit those changes. Commitment can be hard, but we want to make it in this case. And so you're going to go back to your rules view. And there's another way that you can also add nodes to a group. You can pin them. So when you go to the pin by the cert name, you see here that it auto-populates with all the machines that it currently recognizes. We're going to select Windows VM.
All right, because we want that one too.
We want that one too.
We could have got it by a rule, but.
We could have. We could have simply said OS family equals Windows.
Right.
With a lowercase w for those of you who are curious. But we're going to pin them this way so that you can see the different methods in which you can actually engage with the console.
So now.
We're ready.
All three match.
All three match. All right, awesome.
Perfect.
So here's the moment of truth. We're going to find some class, and not class as in like decorum and behavior, but class as in classification. So we're going to look for, see if we have time. Is time a class that we have available here?
We just added the module. Wait a second, it's not quite showing up yet. But what's this say? We did this about 4 minutes ago, so maybe I got to refresh my classes.
So this is a gotcha that happens to a few people. Be sure you're refreshing your classes. Make sure that you are keeping this view current so that you can access the code you need.
Boom.
So there it is. We installed the module, and now it's viewable. So we're going to now pass the parameter that we would like to. In this case, it's simply going to be servers, and we're going to set
Just got one parameter on
just
this
one parameter.
Nice.
We made this code really, really accessible. And so now we're going to simply put that into an array we have, and we're going to use time.nist.gov.
How many you want? Just one?
Just one.
Okay, I'll just do one.
Just one time server for now.
Time.nist.gov.
There you go. Perfect.
Perfect.
You can add that parameter, and we're going to commit that change. So in order to show you all that, it's not all magic, that there's real science happening here, let's actually hop into that Linux machine.
Okay.
And let's see what our current time configuration actually is.
That's the Linux box. Let me look at the NTP.com. Wait, there's no NTP,
What?
nothing here.
Huh?
No,
Well,
sorry.
looks like there's not even been one created. We don't even have an NTP directory or NTP.conf file. So, it doesn't exist. But that's okay, because Puppet's going to handle all of that complexity, and it's actually going to create all the pieces we need in order to manage that resource that we
Oh, we haven't run Puppet yet.
There it is.
Clearly.
So let's kick it off.
All right, let's do it. So Puppet agent -t,
There it is.
also known as -test. Those are for the people that want the inside track, It's kind of a historical
Yeah, I was
detail.
gonna say, those of you who've been around for a while. And so you see that there's a lot of stuff happening. And the stuff that's happening is good stuff. It's what we want to see happening. The Puppet run has been initiated. It's been kicked off. You see it's loading the facts. It's identifying that this system actually needs to be receiving that configuration that we just created.
Yeah, and all this stuff in white ahead of there are all of the, if there are any custom facts that agent didn't have yet, didn't have the code for yet, or any kind of custom types it needs to know about. And like on the Windows, it'll need to know how to handle registry entries.
That's right.
So that gets synced first so that the run will work the way you want it to.
Exactly.
Well, it looked like something happened, Grace.
It does look like something happened. It looked like the class NTP refreshed, and that it's also restarted that service, which is interesting because if you remember, we didn't even have an NTP directory before. So
No.
Puppet, once again, handled a lot of that workload and created the correct directories that we needed in order to make sure that service was running, installed, and configured properly. So now let's actually
check it out.
Let's see if it happened.
All right, let's see if there's an NTP anything. Oh, there's the NTP directory and the NTP.conf we were thinking about. And there it is.
There it is, time.nist.gov. So already with that single parameter being passed through that console, we're able to not only manage time, but create all of the directory structure that we need in order to do so. So it's been configured, right?
That's one machine.
That's one machine, but we had those other machines.
Yeah, we've got 3 total, but it could be 3,000, and this would all just happen the same way. Should we do another one, though?
Yeah, let's do that. And actually, this time we're going to run Puppet in the GUI, which is also really fun. We're big believers in getting in the command line. That could just be an occupational hazard. However, it's really good to understand exactly what's going on and get your hands on the keys. But sometimes you're in a hurry, you have a group, you just want to make sure that all of the systems that are part of that group are getting that configuration. And you can actually run Puppet right here in the console. And you do that by specifying what machine you want Puppet to run on.
Which one should we do?
Let's do Windows.
Cool, because we have a Windows box up as well. And before I jump there, I'll note that you see that blue color there and how it corresponds with the intentional change. So Puppet could see it wasn't fixing something that we had specified before and broke, but we made a change, a new change. Like we weren't managing NTP before, we are now, and Puppet made that change for us.
Exactly.
So pretty cool.
It is. And don't worry, we'll break something later so we can get a correction.
Oh yeah, let's do that. All right, so on the Windows box, let's go look at its node detail.
That's right. And then we're just going to go to Run Puppet.
Oh, I can run Puppet right from here.
And you can not only run Puppet, but you can also run in NoOp. So NoOp is something I haven't mentioned yet, but is definitely what I call a fan favorite. I have a lot of fan favorites, but who can blame me? And NoOp is our simulation mode. So it lets you see what changes would have occurred had a Puppet run been triggered. So it lets you do some rapid testing to see if any of the changes you want to make or any of the classifications you want to apply would either break anything or disrupt any of the processes you currently have running on that system.
Cool. Do you want to do NoOp? Or?
Yeah, let's do it.
All right, why not? We're just going off script, people.
I know,
We just want to do something cool here. So
basically improv at this point.
exactly.
So while this run is completing, what's really cool about this is you're going to get this report back for NoOp as well. So not just in a standard run will you be receiving reporting. Puppet's going to tell you about what would have happened, even though it has not happened yet. So here we go. We have would have had intentional changes. So when you go to view that report, you're able to go to events, and then you're able to filter the event status by NoOp.
Okay, let's see all the things that would have been intentional.
There you go. And it shows you that some registry keys would have been created and some values
Look at
would have
that.
changed.
There would be some changes to that time.nist.gov going on over there.
Exactly. So here you also have that same ability to see what the reporting elements are, where these changes are occurring, what system they're occurring on, and how those changes would affect that machine. So once again, the value of Puppet is not only in just simply being able to run and apply these configurations, but being able to rapidly test any changes. But we want this to happen, Jeremy. So why don't we kick off that NoOp flag and actually do a real run.
Okay, let's do it. So I'll just go back to that node.
There you go.
Very handy. Go to run, take off the NoOp.
And run that bad boy. Okay. And while he's running that, we're going to actually hop into the Windows box just so we can, you know, prove that the time configuration actually did take place.
Okay, so today, if I look at the time configuration,
if we're faster than the run.
Let's see if I can beat it. Look at internet time. So it got set up already in the background. So you can see, if you can see that.
It's very tiny, but it says time.nist.gov. You can see it up here. So already we have the configuration now applicable on 2 of our 3 machines. We've been able to run it from the command line, and when we were able to actually run it in the web interface. So this is exactly what we want to see. We want to be able to make these changes, but we also want to be able to know how to understand what changes are being made. So why don't we actually go back to the overview page of the browser, and let's take a look at the graph. For those of you who had a chance to see the keynote this morning, the product portion of the keynote, the example Vern gave about being able to identify correctional and intentional changes, as well as being able to see that in the node graph. It's a super powerful view. So if we go here to the node graph and we look for WinNTP, because that was the Windows machine.
Yeah, this is the Windows machine here.
So if we type WinNTP, we're going to see that class pop up. And so then we're able to actually drill down on that classification and see already what changed in blue. So you can get that sort of health check overview by using the graph to see what occurred. But the really powerful piece of the graph is that you can identify where those changes were made and the lines of code that affect them. So you can see in the sidebar right here, it tells you the path to that file, as well as the line of code that's managing this.
And then the dependencies, of course, are something if you're wondering, like, well, when exactly do we manage the time service on Windows as well? You can go to that and see who depends on that.
Exactly.
We don't do that until all these other registry keys are managed.
And you see that there are also changes in some of those downward dependencies. So once again, there's power here. So when things go right, everything is great. But when things go wrong, it's very hard to be able to drill down very quickly and effectively to see where those misconfigurations or missteps happen. But with a tool like Puppet, and especially with the graph view and the reporting elements, you can simply look and see this resource is being managed here. I can go here and I can actually fix it. So once again, the value of Puppet has already been improved right after installation and a first initial run has occurred. Let's actually, you know what, why don't we make sure that everything is as it needs to be, and let's break it.
Oh yeah, I like that.
Awesome. Okay. So maybe we should just, you know, it's a long day, you're getting ready to leave, and you accidentally delete the NTP.conf file.
Oh, yeah,
whoops.
I'm root on this box. That's really a great idea.
You really shouldn't have been root. I mean, and now we don't even know like who broke it, like which root was it? Was it Grace root? Was it Jeremy root? Which makes it sound like we might be trees, but that's okay.
This seems like a really good idea.
It's see, no, it's not. So now we don't have an NTP.conf file. What are we going to do about that? Why not even
stop the system here? Why not?
Yeah, why not? Jeremy's running amok in our environment, right? So he's just...
Oh, man. Oh, so I don't even know. So
the NTP.service is not
who
loaded.
Knows?
That's all right.
I'm just going to go crazy. We'll do something. There we go. Boom.
So it still kind of failed to stop, but it kind
of
stopped. So it doesn't matter. We broke something. We don't even ourselves know what we broke.
Yep.
But that's all right, because Puppet is going to remediate that drift. So we're going to run Puppet again.
Okay. And I could run this from the console or from here.
Exactly. You're already in the box, so go ahead and run it from here.
All right. We'll make it so you can see things happening.
There you go.
Doing it live.
Doing it live. So it's running through that same workflow of finding the facts, making sure that it's receiving that catalog. Oh, look, it made some changes. That's great, and it made the changes we needed it to make. It set everything back to as it was. And if we go back to the, to cat that out, we're gonna see that it hopefully has time.nist.gov there.
Yep,
Perfect.
like it's supposed to.
Just like it's supposed to. And we go back to the console, we're going to see what that reporting looks like, because there is a differentiation between the kind of reporting you receive when a correctional change has been made and when an intentional change has been made. So we can see here in the nodes overview section,
Corrective.
there's a corrective change that's occurred. And it's saying that something on the Linux box was wrong. And when you drill down even more, it's going to tell you from the events view and from that in the corrective change. Exactly, it's going to tell you that the NTP.conf file was created. These are the kinds of reporting that you need in order to be able to really identify what issues are occurring and what are those issues. So we already know that this change was made because drift occurred. And that's a super powerful piece for identifying long-standing and ongoing problems.
Awesome.
Excellent.
So what did we do so far? So we got some content down from the forge
We
that
did.
we didn't have to write.
That's right.
We were able to look at it and see that we just had to run one command to get it on our new master.
All right.
And we had to just manage one parameter, which we were able to do through the console.
There it is.
And then we got 3 different machines linked in there so that they'll all have time consistent across them, but it could have been 300, 3,000.
3,000. 3 million.
Whoa,
That's a big environment.
that's a big environment.
All right, so that's how you kind of get up and running and started with Puppet Enterprise. And we have a couple of minutes. We actually have substantial time for some questions, if anyone's got any.
So instead of deleting a file, if there is a change in the file, ntp.conf, let's say I added another server.
Yes.
Let's do it.
Yeah, good question. So the question is, if I didn't just delete the file, but I made a change, because that's, it's kind of coarse-grained, right? If the file's missing, replace it, right? But how about if there's something inside the file? Can we detect that? So I'm going to edit this file instead. And I'm going to go down in this file. I'm going to mess up a couple things, So there's a bunch of things inside of the NTP in the NTP module that have, sane defaults for things. So I don't even know what I'm doing, right? That's not a good idea, I'm sure. Let's get rid of that line and that line. That's terrible. And yeah, let's add some more servers,
What
right?
about time.grace.o'clock? That's my favorite time
Sure,
server.
I like that. Grace.o'clock. And let's just do it with terrible characters in there that are
yeah.
sure to break things.
Go ahead.
Yeah.
That looks good.
Yeah, that's looking really, really terrible. Okay, that can't possibly be a correct NTP configuration. This is bound to cause us downtime and lost money and hours. So what I can do is maybe even just show the NoOp from the command line too.
Exactly.
We haven't done that. We can do that from the GUI.
You can attach the flags here.
Okay, so we'll do -T and we'll do NoOp right from
go.
here. So this will show us whether Puppet detects that any change would be needed to bring it into the right configuration. And it says, yes, indeed.
Apparently you didn't like me being my own time server.
File contents incorrect, not right, going to have to change them. And then that's going to cause the NTP service to have to reread the config file. So let's run it for real and have Puppet make those changes. So no change made yet. And this is valuable, right? If you're wondering if the Puppet code you've written is matching what you've been doing manually in your environment, that NoOp's a great test, right? You say, I wrote some code I think keeps things the right way. You run NoOp, and Puppet says, no, I'm going to delete 5 lines. You're like, oh, wait, I didn't get that code right yet, right? So it's a great back and forth process.
Once again, rapid testing in your environment.
All right, let's look at this thing. Oh, and actually, you could see it. I should have left up the log view. You can see what we did. See the minus sign? Puppet deleted that line, didn't like that. It added in these 2 lines that I had imprudently removed.
The 6.
And then it fixed this whole thing up here, the panic, so that now we've got a proper file back again with the right server in there and all that. So, yep.
Great question.
More questions. We kind of breezed over the agent installation piece and anything around that. I don't know if there's any questions there or about content. Here's a question in the back.
I'm just wondering, is that file being managed, is that part of the module, or is it like adding that server in there, making sure that line is in there?
Yeah, no, great question. So let's show you how this breaks down a little bit. And just to make it make it easy, I'll just show you, since this code is all on the master, and in fact, we saw in our GUI here that there were things that we actually had changes when we were looking at that node graph. Remember when we saw this, here's that ntp.conf that was changed, and I can even do that. I can say, like, just show me, you know, things that are changed, for example. But if we drill into that, you can see that that file is managed from here, from this file on our master and on line 34, right? So I'll go on the master here, and typically this is code that you would have in Git, right, in version control that gets synced to your master. But we're going to just do it here to make it really easy for folks that are starting with a single master. So I'll go there, I'll go to line 34, and there we go. There's the file, our NTP config file, which, depending on which OS we're running on, this NTP module is designed to handle everything from Solaris to Ubuntu to Enterprise Linux family. And so it's going to go to the right NTP config file, make sure it's there, set it to have root as the owner and group, and then it's going to set the right file mode depending on the OS, and then it's going to template the content. So we actually have a template, again, per operating system family that's going to be appropriate. And so we're going to pull in good default values. And so this NTP module is really pretty cool. And it's one that's supported. It's a Puppet Labs NTP module supported on the Forge. So it takes care of all those defaults for you, so you don't have to worry about them. If you'd like to tweak any of those dials and knobs, that was amazing.
That was great.
Yeah, then you can do all that. But out of the box, it just works. And we're taking advantage of that and using just that server's parameter that it cares about and passing that on through. I think because let me actually just show you, just for fun, the actual NTP class itself. And you're going to see all the all the knobs and dials in here. So check it out. There are a lot of things that you could manage in here, but we're saying, you know, really, at the end of the day, the only one we cared about was servers. That was the only one we needed. And so in the modules that we wrote that leveraged this, all we did was kind of pass through that server's value to this guy. And so again, this is showing how you can use modules that are already on the Forge and abstract away the details that you don't care about. I think we've got in here, here's our time module. And if I show you what that looks like inside, you're going to think, oh, that's really simple. Yeah. So in the case of Windows, we use our WinNTP module that we downloaded. In the case of anything else, all the Unix, Linux stuff, we just call NTP and pass in whatever servers we got, we pass it on through. So it's showing this is an example of how you could wrap content and simplify it and use that in your environment.
And another thing that I like to mention when Jeremy talks about being like drilling down and looking at the code, a lot of people are always concerned about, well, what if I want to manage something Puppet's not currently managing and I don't know where to find the code for it? And from the command line, you can simply do a Puppet resource and then name your resource. So if we do a Puppet resource.
What do you want to do, Grace?
Let's do package.
Cool.
It's going to show us all of the packages that are installed and what versions are running on this system. So Puppet isn't this is a fresh box. Puppet isn't managing all of these packages. However, it's telling us what they are, what version that we have, and how to write the code that would actually create a configuration to manage this. So it's giving it that answer, that response back to you in Puppet code so that you can make changes and apply your own created classifications and modules right here from the command line. So once again, this is another really cool feature that speaks to kind of what you're asking. Well, what if Puppet isn't managing something? That's okay, Puppet can, and Puppet will tell you how to manage that.
Yeah, and this is part of the introspection that Puppet uses in order to determine if the box is already in the right state. We've said NTP should be set up, which means inside the NTP module, it's managing the NTP package, like you see here. It's making sure the NTP Comm file is set up right. It's making sure the service is running, et cetera, right? It's doing all those things. And so Puppet needs to know, are we in the correct state or not yet? And so we said a package needs to be there. It looks and says, yep, there's the package, it's good. We said the file needs to be there with this checksum, right, these contents. No, there's something wrong. We need to go correct that, right? So we're able to introspect, and you can use that mechanism like we just did to explore the resources on your server. So what's another one?
Users, that's a really valuable one.
Puppet resource
User. Yep.
And this will show me all the users, and it's a Vagrant box.
Yep.
There you go.
So it's got a lot of that stuff running on it.
So that's another really fun, easy way to start is to say, hey, I want to look at one particular user, like the user root, and I want to make sure the user root is consistent, or the local administrator user on Windows is consistent across all my machines. You could provide the Puppet code in your baseline to make sure that was the case, right? One password hash everywhere that you can centrally control versus having everybody change things whenever they want. Yeah, question over here.
So on your Windows host, what are you running the Puppet agent under? Is it a local account, or are you running it under a domain account? And what kind of privileges does it need to run on that host?
Yeah, so I believe it runs, and we got Josh in the room, so it runs as a local administrator.
Sorry, I missed the question.
Oh yeah, the question is the Windows user, the Puppet user that we're running the agent run under on Windows.
Yeah, by default, it runs as local system, but you can configure it to domain service account.
Perfect. Yeah, and then the experience, I should note, the experience over on the Windows side is exactly the same, right? So you want to introspect, run Puppet resource user. There you go. These are my 2 users that I have currently configured on this machine, local users. Or if I'm looking at packages or services or scheduled tasks, things that are particular registry key, I want to see what that's set to. I can do that same introspection, and I get back real live Puppet code. So I can say I said, this is a popular one. Sometimes when you're doing testing and you don't quite have your DNS set up right, you might even need to do a little host file stuff. You can see we actually did a host entry for our master, so this agent knew how to talk to the master. But that code right there is Puppet code. You can just go and copy that and have that applied across a set of machines that are consistent.
Yep.
Great questions. Other questions? Still have about 3 minutes to go.
That's right.
How many people, just a quick poll, how many people are using Puppet or Puppet Enterprise right now? Ah, cool. All right, and then how many of you are kind of at the early stages of your adoption? Cool. Yeah, awesome. Yeah, and so does this give you a little bit of insight of how you could maybe do a useful starting thing? I'm getting some head nods. Yeah, literally, I mean, and it sounds kind of trivial, right? You're like, okay, great, they manage time, big deal. When you talk to some of our largest customers who had the most challenging environments, and some of these challenges like security or just things not working because time was off or whatever, laying down a firm foundation, a baseline that you can actually build your app layer, et cetera, on top of, and you can ensure security and compliance and that things will just work right, it's just so valuable. And it's also a great entree when you're trying to make that cultural change that's necessary, when you're trying to say, hey, other group that we've got a silo, walled off kind of relationship with, we're hearing from the top that we need to get the DevOps, right? We're hearing that we need to work together. Can we just work on this one thing? Can we just get time consistent? Or something like that, right? That's something you can usually get a little buy-in, get some success, have a joint win together, do a presentation to your colleagues or what have you, and then you can think about, okay, what's the next low-hanging fruit thing that will bring the company a lot of value and that we can use Puppet together on? So encourage you all to go out and try that and in your labs and hopefully soon in production.
Yep.
What do you think, Grace?
I think that that's a great place to start. And once again, I can't stress enough, having the ability to have multiple teams use the same tool in the same way. I think that the greatest value add, and when we were putting this talk together, what really struck me, even though I use the product all of the time. We use it in our demonstration environment, we use it for ourselves, we talk to customers about it, but the simplicity of use for everyone. As you can see, the workflow didn't change when we went to a Windows machine. We were able to use the same commands, we were able to interrogate the system in the same way, view the reporting in the same way, and having that uniformity is actually very powerful.
Same underlying language. Yeah,
There
all
it
that.
is.
Cool. Well, thank you very much.
Thanks for coming.